Hi, today I'm going to talk about how to find the distance between 2 points on a coordinate plane. There are multiple ways to find the distance between 2 points. I'm going to briefly explain one way, and then I'm going to focus mostly on my favorite way. So briefly, let me just show you, when I talk about the distance between 2 points, I really mean, let's say we're on a coordinate plane just like we have here, and we need to find the distance between point B and point C. The distance between these 2 points is this straight line right here. Well, okay, this pretend straight line, if I could draw a straight line. Let's try this again. There we go. It's this straight line if I could draw that straight line. Okay, let's see. There we go. Now we're talking. That didn't work either. That's okay, whatever. You get the gist. So we're finding that distance, but that's not something we can just count like, oh, 1, 2, 3. Because we can only count if we're actually, count 1, 2, 3, if we're actually on the coordinate lines. So the first way, which is honestly a very common way for finding the distance between 2 points, is using the distance formula. This is the distance formula. The distance between 2 points equals the square root of the x value of the second point minus the x value of the first point, close the parentheses and square it, plus parentheses the y value of the second point minus the y value of the first point, close parentheses and square it. And honestly, the more you practice this distance formula, the faster you'll get at it, and it's pretty simple. That being said, it's actually not my favorite way to solve for the distance. So this is a great strategy. Please use it if this is something you're familiar with. I'm going to show you a different way. So back here, to find the distance between these 2 points, I could use the distance formula, or I could just draw a right triangle and use Pythagorean theorem. So here I'm going to draw a line straight down, and here I'm going to draw a line straight across, and boom, I've now created a 90-degree angle where this is a leg of my triangle, this is another leg of my triangle. This distance between the 2 points is the hypotenuse of my triangle. So this leg is 1, this leg is 3, and this distance, I could even call it D for distance, is my unknown. So now I can use Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the 2 legs. So one of the legs is 1 squared plus the other leg is 3. So 3 squared equals, we could leave it as c squared, or we could call it d for distance. Doesn't matter. It doesn't matter what letter you use. What matters is that this part is the hypotenuse. Okay, then squared. So 1 squared is 1 plus 3 squared is 9. Still is just our distance squared. 1 plus 9 is 10 is our distance squared. Now, we're not actually done. The distance isn't 10. We have to take the square root of both sides because d is not actually by itself. It has this little square. So the opposite of a square is a square root. So now we have d equals. Now, if the question asks for the exact length, well, the exact length is the square root of 10. You would literally type square root 10. That would be your exact answer. If it asks you for an approximate answer, or if it asks you to round to the nearest hundredth or something like that, then in your calculator type square root 10 equals, and it's 3.1622 and so on and on. And so maybe it says round to the nearest hundredth, that's 2 decimal places. So that's 3.16. That equals our distance as an approximate or a rounded number. So I'm going to show you another example. Let's say I need to find the distance between point C and point D. This is a really easy one. Sometimes people get caught up in trying to solve and using lots of math. This is a straight line. I can just count 1, 2, 3, 4, 5. Boom, the distance there is 5. That's easy. Okay, well, now let's try a little bit more difficult one. How about the distance between D and F? Now, again, we could use that distance formula that I mentioned earlier. I'm just going to use Pythagorean theorem. I'm going to create a triangle with a 90-degree angle. This side length is 2. This side length is 3. And now I can use Pythagorean theorem. a squared plus b squared equals c squared, where a and b are the two legs of the triangle, so 2 and 3. So 2 squared plus 3 squared equals, this is my distance. I could leave it as c, or I could put it as d for distance. The letter doesn't matter. What does matter is that this is the hypotenuse, so it is not touching the 90-degree angle. Instead, it's across from the 90-degree angle. So 2 squared is 4, plus 3 squared is 9. That's going to equal c squared. 4 plus 9, that's 13, equals c squared. Take the square root. Now, same as before, if it asks for an exact answer, then the exact answer is square root of 13, because you didn't have to round any decimals. You didn't cut off any decimals, you didn't round any decimals, so you know the exact answer is square root of 13. Or it's going to ask you for a rounded answer or an approximate answer, so you use your calculator. Square root 13 equals, it's 3.60555. So 3.60555. And maybe they say round to the nearest hundredth. Make sure you read the directions, what they ask you to round to. I just like the hundredth a lot. So that's 2 decimal places. So it's 3.6. Now I have to decide, do I leave it as a 0 or does it go up to a 1? So I look at this 5. Because it's 5 or larger, that means that this 0 bumps up to a 1. So this is our rounded approximate answer for the distance between D and F. And we could find the distance between F and E. We could find the distance between A and E. Anything like that, this strategy still works. So that is one strategy for finding the distance between 2 points.